All right, so how to name compounds. First, we're going to start with ionic compounds. So ionic means a metal plus a non-metal. So in that case, the metal is always the cation and the non-metal is always the anion. Cation, which is again the metal, is positive. And we use the name from the periodic table. The anion, which is the nonmetal, and it's negative. We change the ending, so we're going to start with the name on the periodic table, so use the periodic table name, but we're going to drop the ending. And add IDE. So we're going to learn two things here. We're going to learn how to name these, and we're also going to learn how to write formulas. So my first one here is sodium and chlorine. So I'm just going to do it off here to the side. So sodium is a +1, so I have +1. Chlorine is -1, so I have -1, and that equals 0. The compounds have to equal 0 when, the charges of the compounds have to equal 0 when you add them together. Since these do, that just means I need one of each, so NaCl. That's how I write the formula. And then I name the cation, and then I name the anion. So my cation, it's the name from the periodic table, so the name of Na is sodium. You should have a periodic table out while you watch these in case you don't know the names. But sodium, and then Cl is chlorine, but again, we're going to drop the ending of chlorine and add IDE, so chlorine becomes chloride. Next, we have calcium, which is 2+, so that means I have a +2 down here, and I have fluorine, which is 1-, which means I have a -1. I need that to equal 0. Since it doesn't, I'm going to multiply this -1 by 2. Now it equals 0. So that means I had to multiply the fluorine by 2. That means when I write the formula, I have 1 calcium and I have 2 fluorine. So I'm going to write that 2 as a subscript. So again, calcium is the cation, so we're going to write the full name. We're not changing it, calcium. And then fluorine, we're going to drop the ending and change it to ide. So fluorine becomes fluoride. Next is magnesium, which is a 2+, and nitrogen, which is a 3-. So I have 2+ and 3-. So those definitely don't equal 0. So because here in like calcium, this one, I could just multiply one of them to get the other one. There's no way I can multiply 3 to get 2. There's no way I can multiply 2 to get 3. So what I actually need to do is multiply them both. So I'm going to go ahead and think about what is their lowest common denominator. And it's 6. That means I'm going to multiply magnesium by 3, and I'm going to multiply nitrogen by 2. So that's going to give me +6 and -6, which is going to equal 0. So when I write my formula, I'm going to start with magnesium and write Mg, and then I'm going to say how many magnesiums do I have? I have 3 of them. And then I'm going to write nitrogen. And how many nitrogens do I have? I have 2 of them. So Mg3N2. So that's how I figured that out. Mg is our cation, so it's going to keep its name of magnesium. Nothing gets changed, but nitrogen is our anion. So we're going to change the nitrogen ending to nitride. Again, you're adding the IDE, nitride. Our last one, aluminum. Aluminum is 3+. And phosphorus is 3-, so that's +3 and -3. So that equals 0. So I don't need to do any multiplying. It means I have 1 aluminum and 1 phosphorus. Aluminum is its cation, so it's going to keep its name, no change. And then phosphorus becomes phosphide. Again, I'm going to drop the ending and add IDE. Phosphorus becomes phosphide. So that's simple ionic compounds. We call it simple because these were all monatomic ions. There were no polyatomic ions in there. But you will have polyatomic ions. So let's go ahead and do those. So for the cation, the rule stays the same. If I number these, let me number them. So the cation, the rule stays the same. Anion, for monatomic, the rule stays the same. But 3, the polyatomic ion. And so 3 kind of trumps the other 2 rules. Polyatomic keeps its name. There is no change. No change to the name. So whatever it says on your list, your polyatomic ion list, is what you should be writing down. So if it's not polyatomic, like this one and our first one, sodium, that's not polyatomic. So it's going to use rule number 1 since it's positive. PO4 3- is polyatomic, right? There's 2 capital letters there. So we're going to use rule number 3. So I'm going to start first by writing the formula. Sodium is +1 and phosphate is -3. So I have a +1 here and a -3 here, and they need to equal 0. That means I'm going to multiply my sodium by 3. So I have Na3 and then PO4. I have 1 PO4. Phosphorus is phosphate is PO4. So rule number 1 is the cation rule, right? So it's going to keep its name. Na is sodium, no change to it. And then the anion here is a polyatomic ion. So polyatomic ion also keeps its name. So PO4 is phosphate. So you're going to have that chart out unless you've already memorized all of those. You're going to need to have that chart out in order to do anything that has a polyatomic ion. So here we're going the other way. You will have to do this on your worksheet. You're going to have to go both ways, where I give you the ions and you write the formula and the name, or I give you the name and you write the formula and the ions, and sometimes I'll even give you the formula and you give me the name and the ions. So you're going to see it all 3 ways. So ammonium is a polyatomic ion, so it's on your list. It looks like this. It's NH4 with a +1 charge. And then chloride. Notice it has the "ide" ending. That means it was monatomic. It came from the periodic table. So chloride was chlorine, Cl. And if you look at your periodic table and you look at your charge, it's in group 17. It's underneath fluorine. Chlorine has a -1 charge. So just writing this off to the side, I have NH4 with a +1 charge and chlorine with a -1 charge. So I have +1 and -1, that equals 0. Therefore, I just need 1 of each. So NH4, I need 1 of those, and chlorine, I need 1 of those. So there's my formula for ammonium chloride. Last one, I have aluminum, which is 3+, and carbonate, which is 2-. So here I have 3+, and here I have 2-. They don't equal 0. So just like before, I need to think of their lowest common multiple, which is 6. So I'm going to multiply my 3 by 2. So I'm going to have 2 aluminums. I'm going to multiply my -2 by 3. So that's going to give me +6 and -6, whoopsie, which equals 0. Okay, so how many aluminums do I need? I need 2. And how many carbonates do I need? So CO3, how many do I need? 3. I need 3 of them, which means I need to put parentheses around it. In the first 2, in these 2, I didn't need parentheses because I only had 1. But if I have more than 1 of my polyatomic ion, I need to put parentheses around it. This tells me I have 3 carbonates, and carbonate is a CO3. Finally, I'm going to name it. Aluminum keeps its name because it is our cation, and then carbonate keeps its name because it is a polyatomic ion. Aluminum carbonate. So the last type that we're going to have is, so far we've covered if it's a cation, if it's an anion, if it's a polyatomic ion. The last type is if it's a transition metal. So in your periodic tables that sort of look like this, right? The transition metals are here. So kind of like that. So anything in there where we don't know the charge, those are the ones that we're referring to if we don't know the charge. So you guys have the periodic table with all the charges written on it. If you're looking at your periodic table and that element doesn't have a charge, we use the name. These are all cations. So cations. We're going to use the name on the periodic table, and we're going to add a Roman numeral to tell the charge. So because we don't know the charge from the periodic table, that means we need to tell the charge in the name. So just as a little refresher, Roman numeral 1 is I, Roman numeral 2 is 2 I's, Roman numeral 3 is 3 I's, Roman numeral 4 is IV, Roman numeral 5 is V, and Roman numeral 6 is VI. So that's probably as high as you're going to need to go, but just as a little reminder in case you didn't remember. All right, so first here we're going to write the formula. We have Fe 2 plus and O 2 minus, so that's a 2 plus and a 2 minus, which equals 0, which means I need one of each. So FeO, and then when I name it, I'm going to name it as iron. Fe is iron, and then I'm going to find it, and I'm going to say, oh my gosh, it's a transition metal. I need a Roman numeral. So I'm going to go back and I'm going to look at the charge. It had a charge of +2, so I'm going to write Roman numeral 2. And then I'm using that rule number 2 about anions. So oxygen changes its ending to oxide. So iron 2 oxide. The next one, Fe 3 plus and O 2 minus. So that's +3 and minus 2. So that does not equal 0, so I'm going to need to multiply. Again, their lowest common multiple is 6, so I'm going to multiply the 3 by 2 and the 2 by 3. That's going to give me +6 and -6, which equals 0. So how many irons do I need? Fe, I need 2 irons. And how many oxygens do I need? I need 3 oxygen. So when I'm writing this name, iron, again, I look and I say, oh my gosh, it's a transition metal. I need a Roman numeral. Again, it's the charge, not how many. A lot of people for this one want to write Fe or iron 2 because there's 2 of them. That is not correct, right? The iron 2 is this one here that only shows 1. It's because the Roman numeral tells you the charge. So this is iron Roman numeral 3 oxide. Okay, so I can't, this is copper and fluorine, but I can't go straight to the name because I'm going to look up copper on the periodic table and see that it's like right here. They're not next to each other, but I ran out of space. And you're going to realize it's a transition metal and you need to write the charge. So I'm going to say copper and I'm going to say, oh my gosh, I don't know the charge, but I know the charge of fluorine is -1 and I know that it has to equal 0. So that means copper has to be +1. So copper is a +1 and iron is a -1. So now when I write the name, I can write copper, Roman numeral 1 to tell me the charge of copper, and then fluoride. I'm going to change the ending of fluorine to fluoride. Finally, our last one here, lead 2 carbonate. So lead is Pb. And if you look at your periodic table, it's like over here. We don't know the charge of it, but it's here in the name. So the charge is +2. And then carbonate on your polyatomic ion list is CO3 with a 2- charge. So that gives me a 2+ and a 2-, which equals 0. So I just need one of each, PbCO3. So on your notebook, you're gonna have to do a bunch of those. Ones that were like these original, like quite simple ones, and then we're gonna make it a little harder with polyatomic ions, and then a little harder with transition metals. There is some examples in your notebook. If you need more, please let me know on the discussion board. Thanks.